need to connect a remote SSE server to your local development environment without rewriting client code. You'll see exactly how to bridge transports by exposing a remote MCP server via local stdio. Just 3 lines of setup to make remote tools behave like local ones. The pattern handles all the session isolation and protocol forwarding automatically. From FastMCP, import FastMCP. From FastMCP server proxy, import proxy client. Hash bridge remote SSE server to local stdio. Remote proxy equals FastMCP as proxy. Proxy client, http://example, com/mcp/sse. Name equals remote to local bridge. Hash run locally via stdio for Claude desktop. If name equals main. Remote proxy run. Hash defaults to stdio transport. This demonstrates the proxy pattern for transport bridging, creating a local gateway to a remote MCP server. The concept revolves around abstracting server location and transport details behind a unified interface, where the proxy handles all request forwarding and response relaying. What makes this distinctive is the complete transparency. Clients interact with the proxy exactly as they would with a native server, unaware of the remote delegation. The pattern works by establishing a bidirectional communication channel where the proxy maintains session isolation for each client request. Advanced MCP features like sampling, logging, and progress updates flow through the proxy automatically, preserving the full protocol capabilities while adding transport flexibility. This separation of transport concerns from business logic enables seamless integration between different environments, whether bridging HTTP to SDDIO or connecting cloud services to local development tools. This approach solves the problem of transport incompatibility and location dependency in distributed systems. It enables scenarios like local debugging of remote services, secure exposure of internal tools, or gradual migration between transports without client-side changes. The trade-off is added latency for each forwarded request, which makes this ideal for development, integration testing, or controlled access scenarios, but less suitable for latency-sensitive production paths where direct imports or server composition might be preferable. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tools and servers. It provides the foundation for both local execution and remote proxying, which we use here to bridge the SSE server to stdio. From FastMCP server proxy, import proxy client. This imports proxy client, the FastMCP component that handles remote server connections via server-sent events. It enables bridging a remote MCP server to local stdio, which is exactly what this script needs to relay messages between the remote endpoint and local processes. Hash bridge remote SSE server to local stdio. Remote proxy equals FastMCP as proxy. This creates a proxy bridge between a remote SSE server and local stdio. The asProxy method transforms the remote connection into a local FastMCP-compatible interface, enabling seamless integration with tools expecting local transport. This pattern maintains protocol compatibility while abstracting the network layer. Proxy client, http://example, com/mcp/sse. This instantiates a proxy client targeting the remote SSE endpoint. It establishes the connection bridge between the remote MCP server and our local proxy, handling all SSE protocol details under the hood. The URL points to the server-side stream will mirror locally. Name equals remote to local bridge. This assigns a human-readable identifier to the proxy instance. Critical for debugging and logging, it distinguishes this bridge in FastMCP's internal telemetry and error reporting. Closing parenthesis terminating the FastMCP as proxy call finalizes the bridge configuration between the remote SSE server and local stdio transport.
Hash run locally via stdio for Claude Desktop. If name == main.
This is Python's standard entry point guard. It ensures the server only runs when the script is executed directly, not when imported as a module. Without this, importing the module would automatically start the proxy bridge.
Remote proxy run. Hash defaults to stdio transport.
This launches the proxy server using stdio as the default transport layer. It bridges the remote SSE connection to local standard input-output, enabling direct integration with Claude Desktop or other CLI-based tools. The run method handles all event streaming and message forwarding automatically. Transport bridging pattern. This proxy implementation demonstrates FastMCP's transport-agnostic design, where a remote SSE server becomes locally accessible via stdio without modifying the backend. The proxy name is purely organizational and doesn't affect routing or functionality. A single line of code bridges entirely different transport protocols while preserving all MCP features.
The bridge that carries everything becomes invisible to what it carries.